Hi guys, we're going to pick up where we left off with algebraic proof. When we left off last class, you guys had just completed your very first algebraic proof, example 2. So let's remind you before you dive into the U-Try how this works. Remember we talked about the format of a formal proof. That given line is always the first thing. You have your very first statement. Your prove line is always your very last statement, so already we know what line 7 is going to be. Let's just go ahead and fill that in. X equals -2. We talked about that your first reason is always going to be given, and that for now, these guys on the right-hand side are going to be the properties of equality that we did the matching with the other day. And then these over here are going to be your algebra steps to solve. Alright, so pause the video, take a minute, and you try. Okay, so let's look. You said, I hope that they subtracted x from both sides of the equation. Anytime you do it to both sides of the equation, you're going to call that subtraction. Then it looks like to get from line 2 to line 3, remember this right-hand side lags behind a step. So from 2 to 3, you write on line 3. They then combine like terms, so that's substitution. And you don't have to write out that that's the combine like terms type of substitution. I just did that for your benefit. Then line 4, I knew I needed to do subtraction. So I subtracted 8 from both sides. Then substitution, again, this is the combine like terms type of substitution. Then they told me I needed, it looked like I needed to do division since I was dividing both sides of the equation by the same thing. And then lastly, I'm cleaning up, I'm simplifying that problem, which we're always going to call substitution. Anytime you're cleaning it up, simplifying, combining like terms, anything like that. So I hope you did well on that. So here is another one from scratch, completely blank. You may be already ready to go ahead and do this again. If so, feel free to fast forward the video, try it yourself, and check the answer at the end. At this point, I hope you're feeling comfortable writing the proof and the given. And so this is 3x minus 8 equals 4 plus x for always our first statement is that given statement. Our proof is always the last statement. And then our first reason is always given. So one of the things I wanted to show you this time is that you don't have to painstakingly write out your subtraction or addition horizontally every time. So for example, if I wanted to for step 2, let's see, my first step would probably be that I would subtract x from both sides. So I'm going to write down subtraction in order to solve. If I wanted to, I can just go ahead and write 2x minus 8 equals 4, because that's what I would get if I subtracted x from both sides. But you don't have to actually show that you subtracted x from both sides. It was helpful up here just to see what they did, but if you want to just write down what your result of the next step would be each time, that's fine too. So I want to give you a chance to try this on your own, so if you would please pause the video and then check back and see how you did. Okay, so I did addition next. I added 8 to both sides. And then I called that, so I did my addition, then I showed my division in step 4, and then substitution to clean that up. So another thing about proofs, there's no exact one right way to do it. So if you did the horizontal subtraction, addition, and then in step 1 subtraction, that's fine. If you did this proof in 5 steps, and maybe you didn't show this step, you went straight from here to here and called it division, that's fine too. You don't have to do it in the number of steps that they suggest, and yeah, so just so long as everything is explained and accounted for, it doesn't have to be done exactly like I did it. Okay, now we're going to move on to the properties of congruence. These are basically the same things we've seen before with the properties of equality. We knew that reflexive property was when the same thing is literally on both sides of the equation. Angle A is congruent to angle A. The only difference is now they're the properties of congruence because we're dealing with shapes. These are segments and angles, but it's the same idea. Symmetric. It's the same thing, just the order is flip-flopped. B is on the left now of the congruent sign, and A is on the right, vice versa for the original equation. And then transitive is probably my favorite. If angle A is congruent to B and B is congruent to C, since they both equal B, then you can equal them to each other. A is congruent to C. Same thing for segments. I just feel like the angles is a little cleaner. So we're going to plain name that property. So you're just going to look above and decide which property it is. So for this first one, angle K equals angle K, I hope you said reflexive. Second one, RS is congruent to TW. Ooh, I'm missing my segment symbols. TW is congruent to PQ, then RS is congruent to PQ. Looks like since both of these equal TW, they said that RS can equal PQ, and that would be transitive. And I'll let you try the last one. And I hope you said symmetric. Okay, so now we're going to step it up a little bit and use the segment and the angle addition postulates combined with the algebra in our proofs. So remember that these were the part plus part equals whole postulates. Segment addition was for segments, obviously, part plus part equals whole, and angle addition obviously was for angles. These are on your pink sheet if you want to use your pink sheet for reference as we go through this. So we're basically just adding one step at the beginning of our proof. So we have AB is given to be 2y. We're given both the picture and that statement. We're given that BC is 3y minus 9, and that AC, the whole, is 21. Okay, so before we can get to all of this algebra, we have to first set up our equation. And the reason why we can say 2y plus 3y minus 9 equals 21, we have to address why we can say that. And it's because this part plus this part adds up to the whole. And so you have to acknowledge, I'm sorry, it's not angle, Miss Benton. Segment addition postulate. I apologize if you can hear my dog growling in the background. Alright, so you have to acknowledge that this part plus this part adds up to the whole. Then you can go to substituting AB with 2y, BC with 3y minus 9, and AC with 21. Oops. And so because we're replacing each of these segments with their algebraic values, their algebraic expressions, this would be called substitution. And it's the replacing kind of substitution. Again, you don't have to write that out. I just want to be very clear why it's substitution. And then from there, it's just algebra. So if you will, pause the video, take a second, and see if you can do this algebra part on your own now. Okay, so we said that this next line was substitution because they combine like terms, the 2y and the 3y. Then it looks like for the next line, they added 9 to both sides to get from line 4 to line 5. And then lastly, they divided by 5 to get from line 5 to line 6. So we write that on line 6 as division. Alright, same idea in example 6. The only difference is this time it's angles instead of segments. So let's look at the given and what we've got to work with. Whoops. We know that AOB is X and BOC is 2X plus 10. And the whole thing, I've got it way off here to the side, AOC, the whole thing is 139. Okay, so that's our given. And then it says our second line is AOB plus the blue part, BOC, adds up to the whole AOC. So part plus part equals whole. For angles, we call that angle addition postulate. Then from here, we're substituting, we're replacing each of those angles with their algebraic expressions. So that would be substitution. The replacing kind. And again, go ahead and pause the video. I think you've got the hang of this by now and see if you can do this last part by yourself. Okay, so we said we combine like terms. We call that substitution. Then we subtracted 10 from both sides, so that was subtraction. And lastly, we divided by 3 on both sides, so that was division. So on the U-try here, the most common thing that people want to jump over is that line 2 right here. People want to go straight to the fact that 2x plus x plus 6 equals the whole, which in this case is 90 degrees. But you cannot do that step. You cannot address the algebra until you've done the part plus part equals whole for angles. The reason why you can add up those algebraic expressions to the whole is because you're doing part plus part equals whole for angles. So you've got to address why. And I know this is a little bit painful because if you'd been solving this problem on the last test, you probably just would have jumped straight to the algebra. But I need you to slow yourself down. Take the time to do your angle addition postulate. I'll go ahead and tell you that before you do the algebra. Alright, so you try, pause the video, give it a shot. We'll come back and take a look. Okay, so I hope you wrote out your angle parts that added to your whole for the angle addition postulate in line 2. Then in line 3, we know we replace those angles with their algebraic expressions. In line 4, I did substitution. I combined my like terms. And line 5, I subtracted the 6. And in line 7, I divided by 3 to get my final answer. So you may have actually done this proof in 7 steps or 8 steps. Some people like to do line 3 and then show in line 4 that they are combining like terms, line 4 is usually the same. Line 5, they like to show that they subtracted 6 from both sides. And then do a line 6 that's substitution, and then do a line 7 that's division, and then do a line 8 that's substitution. That's fine too. Again, our proofs don't have to be identical. I just need you to somehow address every single thing that was done in the problem and why it was done. So these are why it was done and how we can support that, and then this is what was done. Okay, so for your homework, you've got a few problems in the book, and you've also got the proofs at the end of the notes. So you have problems 1, 2, and 3 here at the end of the notes, and then you've got a few problems in the book, and I'll see you on Thursday. Email me if you have any questions. Thanks. Bye.